Hey, what's up? Today we're going to go over an example problem from the section Right Triangle Trigonometry. So let's go ahead and get started. If you take a look here at the problem, we're being asked to find the angle theta. Angle theta is tucked into this top left corner of a right triangle. And we know this side length of 9 and the side length of 12. Okay, we're going to want to use that information in order to find that angle. The first thing we need to do is identify which side is opposite, adjacent, and hypotenuse. The hypotenuse is always this long leg, or the one across from the 90 degree. So this, let's just put a hypotenuse, H for hypotenuse. Adjacent, kind of meaning next to, is the one next to that angle. So we're going to be analyzing this angle. So adjacent is, these two sides are technically like next to theta, but this one is already labeled as hypotenuse. Hypotenuse can only be that longest side. So adjacent will be this corner. And opposite, as you can guess, would be right here, opposite of that angle or the remaining side, right? So what we're going to do with these A, O, and H's is find out which of these three trig functions we want to choose to use. So we know the adjacent side and the opposite side. So let's figure out which one of these three has O and H only. I see sine has opposite and hypotenuse. We don't know hypotenuse. I'm not going to use that guy. Cosine is adjacent over hypotenuse, has hypotenuse again, so we're not going to use that one. Tangent is opposite over adjacent. So you see opposite over adjacent, it's the ones that we know. So let me circle this in green. Bam. We are going to use tangent equals opposite over adjacent. So let's plug it in. This is how it goes. It's tangent of the angle that we're analyzing. I'm putting theta because we don't know the angle. It's tangent of the angle. What TOA represents as tangent of the angle is opposite length over adjacent length. So it's tangent of this unknown angle is going to equal this known opposite over adjacent side. Okay, you can simplify that if you want to 4/3. The next step here is to solve for theta. So many students of mine will say, oh, do we divide by tangent? Which kind of looks like it, but the problem is that whenever you solve for a unknown, a variable, you always do the opposite operation of what's done to it. So if you have 5 times x equals 3, you're going to divide by 5 because 5 is multiplied to x. In this case, tangent is not multiplied to theta. It's an operation. So the opposite of tangent is tangent inverse. So you're going to do tangent inverse to both sides. Tangent inverse is the opposite operation as tangent, just like dividing by 5 is the opposite of multiplying by 5. So this goes away with this. And what you're left with is theta is equal to tangent inverse of 12/9 or 4/3. At this point, you need a calculator to plug that in. So you're going to make sure that your calculator is in degrees if you want the degree answer, or in radians if you want the radians answer. Most people use degrees, I would say. So if you plug this into your calculator, we're going to get theta equals 53.13 degrees. And that is the answer. See you in the next one.